So we constantly produce a lot of data, for example via social media, public transport, and GPS. But it goes way beyond that. Daily, we upload 55 million pictures, 340 million tweets, and 1 billion documents. In total, we produce 2.5 quintillion bytes a day. That's a lot of zeros. It's ridiculous. We call this big data. But what's actually more important is what you can do with it. To process big data, you don't need huge computers. People work with the cloud, an endless network of normal servers, and powerful algorithms. This way, they can analyze over 1 million pieces of data in minutes. And the result? Well, for example, video streaming website Netflix analyzed the big data of their viewers, like popular shows and watching patterns. This way, they produced a successful series with the perfect combination of actors, directors, and storyline. Right now, the big data of traffic is being analyzed to develop a car that can drive completely accident-free all by itself. And in the future, we can even use the big data of DNA to determine the perfect treatment. This way, curing genetic diseases like cancer would become much easier. And that's just the start.
Cloud computing is the on-demand delivery of IT resources via the internet, with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more. You can deploy technology services in a matter of minutes and get from idea to implementation several orders of magnitude faster than before. This gives you the freedom to experiment and test new ideas to differentiate customer experiences and transform your business, such as adding machine learning and intelligence to your applications in order to personalize experiences for your customers and improve their engagement. You don't need to make large upfront investments in hardware and overpay for capacity you don't use. Instead, you can trade capital expense for variable expense and only pay for IT as you consume it. With cloud computing, you access resources from the cloud in real time, as they're needed. You can scale these resources up and down to grow or shrink capacity instantly as your business needs change. Cloud computing also makes it easy to expand to new regions and deploy globally in minutes. For example, Amazon Web Services has infrastructure all over the world, so you're able to deploy your application in multiple physical locations in just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. No matter your location, size, or industry, the cloud frees you from managing infrastructure and data centers so you can focus on what matters most to your business.
Assalamualaikum and hi, my name is Amira Nurhuda binti Burhan. I will start the presentation with definition of cloud computing. Cloud computing is the delivery of different services through the internet. These resources include tools and applications like data storage server, database, networking, and also software. Other than that, cloud computing is basically accessing computing service over the internet instead of having users' own equipment and software. User can access this service remotely through a web browser or a mobile app anytime they want. Next, I will go over the characteristic of cloud computing as well. One of the key characteristics of cloud computing is self-serving provisioning. This means that user can access and manage their own cloud resources without need of human intervention. Secondly, broad network access. User can access the cloud resources from anywhere in the world using any device with an internet connection. For example, a student can access educational resources and tools from anywhere at any time. Lastly is rapid elasticity. It's referred to the ability to scale up and down computing resources quickly and easily to meet changing demand. For example, a company can scale up its web server resources to support traffic peak during a holiday sale. Following with cloud computing, I will continue explaining more in depth about big data. Big data is the term that describes the large, diverse, and complex dataset that are rapidly growing in volume and variety. These datasets are often large or complex that they cannot be effectively processed using traditional methods. Besides, big data also can come from a wide range of resources, including social media, machine, and transaction. Here are the characteristics of big data. First and foremost is volume. It's referred to the massive size of big data set, exceeding the capacity and capabilities of the traditional data process tools and technique. This data set can range from terabyte to petabytes and even size exabyte. Due to that, these scales require specialized processing power and storage solution. Moving on to the second characteristic, which is velocity. Big data is generated and processed at rapidly increasing speed. This requires real-time analysis to extract meaningful insight and respond to changing circumstances. However, traditional data analysis methods often lag behind the speed of data generation, that making them unsuitable for big data analysis. Lastly is variety. It comes with wide range of format, including structured, semi-structured, and unstructured data. Structured data come with various formats such as spreadsheet and database. Meanwhile, semi-structured data is partially organized. On the other hand, unstructured data is not organized at all, such as text document, image, and video. This variety of data format can make it difficult to process and analyze big data. Here are some examples of how big data is being used today. First, we can see that Netflix uses big data to recommend movies and TV shows to its users. We also can see that Twitter is used big data to identify trends and understand public opinion. These are just a few examples of many ways that big data is being used today.
Thank you, Amira. Assalamualaikum warahmatullahi wabarakatuh. My name is Farfahana binti Isidin. I will continue the presentation about rationale of cloud computing and big data. Cloud computing and big data have revolutionized the way business store and manage their data. The use of cloud computing in accounting has several advantages, such as cost saving, scalability, and flexibility. For cost saving, cloud-based accounting software is less expensive to implement and deploy to multiple locations. So the business don't need to buy or manage servers of or other IT infrastructure to run their accounting software. Cloud accounting software lets users work from anywhere, improve accuracy and compliance, automates manual tasks, and accelerate financial close process. Secondly, scalability. Cloud-based accounting solution offer significant benefit over desktop-based accounting products and manual spreadsheet-based process. Its leading cloud solution automate every accounting task, reducing manual effort, improving accuracy, and accelerate financial close process. Employees can access real-time financial information and collaborate on accounting tasks from anywhere at any time using any capable device. And lastly, flexibility. Cloud-based accounting software provide businesses with flexibility to scale up or down as needed. This means that business can add or remove users, storage, and other resources as needed, without having to worry about the underlying infrastructure. Big data, on the other hand, provide businesses with the ability to analyze large amount of data and gain insight that were previously impossible to obtain. By storing accounting data in the cloud, businesses can access their data from anywhere, at any time, and on any device. This makes it easier for businesses to collaborate and share information with their employees, customers, and partners. Next, big data analytics can help business to identify the trend, pattern, and anomalies in their data, which can be used to make better decisions. For example, big data analytics can help business to identify the fraudulent activities, optimize their supply chain, and improve their customer service. However, there are several challenges associated with cloud computing and big data, such as data security and privacy, cost management, and compliance with regulation. Next, I will continue the presentation about origin of cloud computing and big data. Cloud computing and big data have revolutionized the way business store and manage their data. The origin of cloud computing can be traced back to the 1960s when the concept of time sharing was introduced. This allowed multiple users to access a single computer simultaneously, which was a significant improvement over a previous batch processing system. In the 1990s, the term of cloud computing was coined to describe the process of delivering computing services over the internet. While big data can be traced back to the early days of computing, when businesses began to collect and store large amounts of data. However, it was not until the arrival of the internet and the proliferation of digital devices, such as smartphones, tablets, laptops, which big data became a significant issue. The concept of big data is based on the idea that the more data you have, the more insight you can gain from it. Big data provide businesses with the ability to analyze large amount of data and gain insight that were previously impossible to obtain. In summary, cloud computing and big data have transformed the way businesses store and manage their data. The history of cloud computing and big data can be traced back to the 1960s and the early days of computing respectively. Since then, both technology have evolved significantly and they continue to transform the way business store and manage their data.
Hi, Assalamualaikum. My name is Nur Juhaida binti Jaharuddin. Now, I would like to talk about the challenges of big data. The first challenge of big data is incompleteness. Computer systems operate most efficiently when they can store several things that all equal in size. So data must be appropriately formatted as a first step in data analysis. Consider an electronic health record database that includes fields for each patient's birth date, occupation, and blood type. So what do we do if a patient fails to submit one or more of these pieces of information? The health record will still be stored in the database, but the data will shown as null, indicating that the patient's information shows as unknown. Secondly, is timeliness. The larger the data collection to be processed, the longer analysis will take. There are numerous situations where the outcome of the evaluation is required instantly. If a fraudulent credit card transaction is suspected, it should preferably be reported before the transaction is completed, in which it potentially preventing the transaction from occurring at all. Last but not least is privacy, where it requires strict safeguards against cyber attacks, data breaches, and data loss. In order to improve data security, businesses ought to maintain a strict data confidentiality standards and use legal cloud access management services. Imagine if the data could be obtained through the location-based services. For example, when users hide their identity without hiding their location, an attacker can still determine the identity of the query source based on its location information. There are three opportunities of big data and I would like to explain about it. First is cost saving. It functions to assist companies in improving operations and saving money by finding inefficiencies in business process. This tool can assist business in determining which products are most likely to be returned and in taking efforts to reduce both losses and costs. The businesses could determine which cities have the most product returns or which types of clients frequently exchange their goods. Thus, they can cut down the cost of transportation, logistics, and wastage. Next is market insights. It operates to assist businesses in better understanding their customers. Company can gain insights into their customers' needs and preferences by determining which marketing efforts are most effective and which need to be improved. Analyzing customer reviews allows businesses to evaluate client attitude towards their product. For example, a smartphone manufacturer can detect common customer issues and fix them in the next product release based on those reviews. Lastly, product development. Product development is an essential field in which big data can be used to improve outcomes. Company can discover what item individuals desire and need by analyzing customer data. They can work out efficiently by detecting which areas sell more products and which areas require more attention by watching sales data. Through that, they could find the product solution according to current market trends or build a planned solution for new product launches or extensions of existing products. Now, let's look into the challenges of cloud computing. Technical issues are one of the challenges of cloud computing, where some major malfunction and dysfunction may result in the denial of access to information and data from the cloud at any time and from any location. Cloud computing relies heavily on the internet connectivity. As a result, if the network connectivity is poor, the user may struggle to access their data and application on the cloud. This dependency on internet connection is a key disadvantage of cloud computing, as it means that the ability to access data and use cloud services is only reliable based on users' internet connection. Other than that, security is also one of the challenges of cloud computing. The data is stored offline and can be accessed via the internet. Companies must employ effective security measures to protect their data from cyber threats. These services can be accessed by third parties, so there may be a chance that these services easily harmed and hacked by the hackers. And then you have compliance, where when using cloud services, businesses must address data residency requirements, cross-border data transfer rules, and contractual duties. Cloud hosts have specific compliance certification that they must pass for cybersecurity assurance, so the organization need to find the right provider based on the business industry cybersecurity requirements. Healthcare, financial, and government agencies, for instance, must find cloud providers compliant with various industry standards. If a provider uses a non-compliant host, the business could be liable for high cost penalties and fees after a data breach. After we have looked over the challenges of cloud computing, I would like to talk about the opportunities of cloud computing. To begin with, we have unlimited storage for cloud computing, where storing information in the cloud provides consumers with almost infinite storage capacity. Company would no longer need to be concerned about the running out storage space. Storage can be enlarged at any time for an affordable monthly price. It is extremely beneficial to businesses, particularly those with a large amount of data. They may fill data in various forms such as files, video, audio, and so on. Furthermore, backup and recovery. Service using several redundant backup sites which can assist business continuity and disaster recovery. Because all data is safe on the cloud, backing it up and restoring it is more easier than storing it on physical device. The cloud computing will help the company keep up to date with the copy of the company's data each time the company makes several changes. Last but not least is mobile accessible, where it allows company to be more productive since employees can access their data and application anywhere as long as they have internet connection. A personalized service in the cloud can retain users' interaction histories and continue their engagement even when the touchpoint or device changes. For example, Spotify has worked hard to provide several ways for users to enjoy music, so the users can play music on several types of devices, picking up wherever they left off.
Hi, my name is Amir Muttasim, and I will continue this presentation on explaining about theoretical framework for big data and cloud computing. The first one is information system theory. Information system theory, when applied to accounting, underscores the pivotal role of information technology in optimizing and streamlining accounting processes. This theoretical framework recognizes that accounting functions rely heavily on organized and efficient information systems to collect, process, store, and disseminate financial data. In the context of accounting information systems, This theory emphasized the integration of technology to enhance accuracy, speed, and accessibility of financial information. Information system theory provides a conceptual framework for understanding how these systems contribute to the achievement of accounting goals, such as providing reliable financial reports, facilitating decision making, and ensuring compliance. It guides the design and implementation of accounting information systems, considering factors like data organization, system architecture, and the alignment of technology with the broader organizational objectives in the accounting domain. The example of the company that implement this theory is that Oracle. Oracle, a multinational computer technology corporation, utilizes information system theory in various ways to design, develop, and implement solutions for its client. Information system theory in this context involves understanding how information system can be structured and leveraged to achieve organizational goals. Here's how Oracle incorporates this theory. First and foremost, integrated cloud solutions. Oracle provides integrated cloud solutions, including Oracle Cloud Infrastructure (OCI) and Oracle Cloud Applications, covering various aspects like ERP, Enterprise Resource Planning, and HCM, Human Capital Management, and etc. The implementation done by Oracle Cloud Infrastructure is that they offer a comprehensive set of cloud services, allowing organizations to build, deploy, and manage applications efficiently. Oracle Cloud Application provide a suite of integrated business applications that share a common data model and user interface. Next is Resource-Based View, RBV. RBV views data as a strategic resource that can provide a competitive advantage in accounting. RBV also is a management theory that suggests that the firm's competitive advantage is based on its internal resources and capabilities. The example of company that using this theory is Microsoft. Microsoft Azure is one of the leading cloud computing platforms globally, offering a comprehensive suite of services including computing power, storage, and various data services. To illustrate the implementation of RBV, Azure represents a valuable and scalable resource. It allows Microsoft to offer cloud solutions to businesses, enhancing its competitiveness in the technology market. In summary, Microsoft strategically applies the RBV framework by leveraging its diverse technological resources, investing in innovation, building a strong ecosystem, and protecting its intellectual property. These efforts contribute to its sustained competitive advantage in the technology industry. The third framework is agency theory. Agency theory is relevant for understanding issues of data ownership, control, and stewardship in the context of big data in accounting. Agency theory examines the relationship between principals such as owners or stakeholders as well as agents like individuals or entities hired to perform tasks on behalf of the principals. It addresses issues of control, delegation, and the alignment of interests. The example of the company is IBM. The application of agency theory on IBM is that IBM acts as an agent entrusted with the data of its clients. The company must demonstrate a high level of control and responsibility in managing and securing client data. Other than that, IBM as an agent is tasked with providing reliable and efficient cloud services on behalf of its clients. It must align its interests with clients' interests, ensuring that services meet quality standards and are delivered within agreed upon parameters. It's important to note that the specific application of agency theory principles within IBM may vary based on the context, business units, and client relationships. Companies often adapt theoretical frameworks to their unique organizational structures and challenges. the details of IBM's international practices related to agency theory would be proprietary information. Next framework is innovation diffusion theory. Innovation diffusion theory, developed by Everett Rogers, explains how innovations spread through social systems over time. It identified different adapters, categorized and factors influencing the adoption process. Innovation diffusion theory helps understand the factors influencing the adoption of big data technologies in accounting firms. The example of the company that implement this theory is Intuit. One of the innovation diffusion theories is agile development practices, where the company Intuit adopts agile development practices, allowing for frequent releases of new features and updates. This continuous innovation keeps the product relevant and maintains user interest. Moreover, incorporating user feedback is also related with innovation diffusion theory. Intuit considers user feedback and not only for addressing concerns, but also for guiding the direction of future innovations. This ensures that the product evolves in response to user needs and preferences. In summary, Intuit's applications of innovation diffusion theory involves a strategic and user-centric approach to introducing and promoting new technologies within its product. By understanding different adapter categories, utilizing effective communication, and addressing concerns through user feedback, Intuit successfully navigates the innovation diffusion process within the small business and accounting community. Last but not the least, advanced analytics and AI integration. Advanced analytics and AI integration in accounting involve leveraging sophisticated computational techniques to extract actionable insights, automate routine tasks, and enhance decision-making processes. In the accounting context, advanced analytics often includes statistical modeling, predictive analytics, and data mining, allowing organizations to identify patterns, trends, and anomalies within financial data. AI integration introduces machine learning algorithms that can learn from historical data, automate repetitive tasks like transaction categorization and reconciliation, provide accurate cash flow forecasting, and even detect potential fraud through anomaly detection. These technologies streamline accounting operations, improve accuracy, and empower financial professionals within data-driven insights, ultimately contributing to more efficient and strategic financial management for businesses. The example of the company that using this theory is Xero. Machine learning for categorization is being incorporated into Xero, where they will employ machine learning algorithms to automatically categorize and reconcile transactions. This helps businesses save time by reducing manual data entry. The way this functions is by making the system learn from historical data and user corrections to improve accuracy over time. In this case, it can recognize patterns in transactions and suggest appropriate categories. Furthermore, cash flow forecasting, in which Xero incorporates AI-driven cash flow forecasting to help businesses predict their future financial positions. By analyzing historical data, payment patterns, and other financial activities, Xero's AI models generate forecasts to provide businesses with insights into their future cash flow, aiding in the better financial planning.
Hi, my name is Muhammad Fahmi Ma'arif, and now I would like to talk about the challenges for big data and cloud computing related to accounting. Now, first of all, is information system theory. Information theory in the context of accounting involves the communication and process of financial data to facilitate decision-making and reporting. One of the fundamental challenges in this domain is the ever-increasing volume of financial information generated by organizations. As business grow and transactions multiply, handling and analyzing vast datasets become cumbersome. The sheer complexity of financial transactions, coupled with the need for accuracy and precision, poses a challenge in terms of information processing. Now, another challenge is the potential for information overload, where decision makers may struggle to extract meaningful insights from the abundance of data. This can lead to decision fatigue and hinder the effectiveness of accounting processes. Additionally, ensuring the confidentiality, integrity, and availability of financial information is crucial, and the risk of data breaches or unauthorized access pose a significant concern in the realm of information theory in accounting. The second challenge is resource-based view or RBV. The resource-based view in accounting focuses on understanding how a firm's unique resources and capabilities contribute to its competitive advantage. Several challenges and solutions arise when applying the RBV framework to accounting practices. One significant challenge is the identification and measurement of intangible assets, such as intellectual capital and brand value, which are often not easily quantifiable using traditional accounting methods. These intangible assets play a crucial role in a firm's competitive advantage but can be challenging to assess accurately. Moreover, the dynamic nature of business environments poses a challenge in capturing the evolution of resources over time. Accounting frameworks may struggle to adapt to changes in the value and relevance of certain resources, especially in industries with rapid technological advancement. The difficulty in assessing the interplay of resources and capabilities in creating sustainable competitive advantages adds another layer of complexity. Now, the next challenge is agency theory. Agency theory in accounting addresses the relationships between principals and agents and the challenges that arise due to diversion, interest, and information asymmetry. One of the primary challenges in applying agency theory to accounting is the potential conflict of interest between shareholders and managers. Managers may prioritize their own interests over those of shareholders, leading to agency costs and potential wealth erosion for shareholders. Additionally, information asymmetry poses a challenge as managers may possess more information about the company's operation than shareholders, making it difficult for shareholders to monitor managerial action effectively. Now is innovation diffusion theory. Innovation diffusion theory explores the adoption and spread of innovations within a social system. When applied to accounting, IDT or innovation diffusion theory faces specific challenges and requires tailored solution. One major challenge is the resistance to change within the accounting profession. The conservative nature of accounting practices and the adherence to established standards makes it difficult for new innovations to be accepted. Professionals may be reluctant to adopt new technologies or methodologies due to concerns about the reliability of innovation or the potential disruption to existing workflows. Another challenge lies in the diverse needs and characteristics of accounting firms, ranging from small practices to large multinational corporations. Innovations that may work well for one type of organization may not be suitable for another. Tailoring solutions to the specific requirement of different entities within the accounting ecosystem is essential. This may involve developing scalable technologies that can be adapted to various organizational sizes and structures. The pace of technological advancements is another challenge associated with IDT in accounting. The rapid evolution of financial technologies or fintech and data analytics requires accounting professionals to stay abreast of the latest developments. Continuous education and professional development programs are crucial to ensure that accountants have the skills and knowledge needed to effectively integrate new innovations into their practices. Now, last but not least, is advanced analytics and AI integrations. The integration of advanced analytics and artificial intelligence (AI) in accounting presents numerous challenges and requires thoughtful solutions to fully realize the potential benefits of these technologies. One major challenge is the scarcity of skilled professionals who are proficient in both accounting principles and advanced analytics techniques. The traditional accounting workforce may lack the necessary expertise to harness the full power of AI, leading to underutilizations of these technologies. Now, another challenge is the interpretation of complex AI-generated insights and analytics outputs. The black box nature of certain AI algorithms can make it challenging for accountants to explain how specific conclusions or predictions were reached, raising concerns about transparency and accountability. Now, let's move on to solutions to big data and cloud computing related to accounting. The first solution for information system theory is to address this challenge. Technological solutions play a pivotal role. Advanced data analytics tools and artificial intelligence can help automate data processing, identify patterns, and generate valuable insights efficiently. Implementing robust cybersecurity measures and encryption protocols can safeguard financial information from unauthorized access, ensuring data integrity and confidentiality. Moreover, adopting cloud-based accounting systems can enhance scalability and accessibility, allowing for more streamlined and collaborative financial reporting. Now, the solution for resource-based view or RBV is accounting practices can integrate advanced valuation models and metrics that go beyond traditional financial statements. Methods such as the balanced scorecard and intellectual capital reporting provide frameworks for assessing and reporting on intangible assets. Additionally, there is a need for a more forward-looking approach in accounting, incorporating predictive analytics and scenario planning to anticipate changes in the value of resources. Collaboration between accountants and professionals from other disciplines, such as technology and strategy, is essential. This interdisciplinary approaches enables a more comprehensive understanding on how resources contribute to competitive advantage and helps in developing innovative accounting practices that better capture the nuance of the RPV. Furthermore, continuous education and training for accountants to stay updated on emerging valuation techniques and evolving businesses landscape are crucial for effectively applying the RBV framework in accounting. Now, the solution for adjacency theory is one solution involves aligning the interests of managers with those of shareholders through incentive mechanism. Performance-based compensation, such as stock option or bonuses tied to financial performance metrics, can encourage managers to act in the best interest of shareholders. However, designing effective incentive structures requires a careful balance to avoid unintended consequences and excessive risk-taking. Another solution involves improving transparency and communication between principals and agents. Enhanced disclosure requirements and clear reporting standards help reduce information asymmetry, allowing shareholders to make more informed decisions. Regular and comprehensive financial reporting, along with communication channels like investor conferences and webcasts, can facilitate a better understanding of a company's performance and strategic direction. Now, moving on to the solution for innovation diffusion theory. A conducive environment for innovation adoption must be created so that firms can implement comprehensive training programs to familiarize accounting professionals with new technologies and methodologies. Additionally, fostering a culture that values continuous learning and experimentation can encourage practitioners to embrace innovative approaches, breaking down resistance to change. Additionally, concerns related to data security and privacy present challenges in the adoption of certain innovations. As accounting involves handling sensitive financial information, ensuring the integrity and confidentiality of data is paramount. Solutions include the implementation of robust cybersecurity measures, adherence to data protection regulations, and careful selection of technology partners with a strong focus on security. Now, last but not least, the solution for advanced analytics and AI integrations. It involves in investing in training programs and educational initiatives to upskill accountants and finance professionals, ensuring they possess the necessary proficiency to leverage advanced analytics and AI tools effectively. Furthermore, include the development of explainable AI models that provide clear and understandable rationale for the outputs. This is not only addresses the interpretability challenge, but also enhance trust in the AI-generated insights among accounting professionals and stakeholders.